Hey, hi. This is Varun. So for pattern recognition course, my project is human activity recognition with convolutional neural networks. My instructor is Dr. Wu. So first of all, what is meant by human activity recognition? Human activity recognition is just the process of identifying the activities of the humans in a given picture. So, by identifying the human activities, what is the purpose or why is it required to identify the human activities? In context aware applications or in ubiquitous computing, if you consider, the actions need to be performed based on the human activities and you need to act accordingly. So, identifying the human activities or the state in which the humans are present is very crucial in ubiquitous computing and will and in assisting the sick and disabled, home based rehabilitation and security related, like it has many number of applications, from security related applications and logistic support to location based services. Like if you take the first application in assisting the sick and disabled, like many disabled people wants to live or elderly people alone. So to assist them, we need to find the state in which they are present so that we can act accordingly. So what is the problem in finding these activities? Like it is very difficult to extract the effective features that distinguishes the activities, because there may be many activities. If you take a certain picture, there may be many number of people with varied number of activities. So to identify or to distinguish among those activities, we need to get the features effectively. So for a particular activity, what features will make this activity? So the solution, like we have existing solutions, but those approaches are based on heuristic. Like they have some set of features that are applied in to get the extract and to get the features. But human activity recognition is a very dynamic in nature, because each activity may be, each picture is different, and in some pictures there may be many activities and in another there may be few activities. So it is important to have a systematic approach that depends on the task itself rather than having a standard features applied to a number of tasks. There should be an approach that can learn features from the task. By analyzing the data, it need to extract the features. Once the features extracted are accurate, then the classifier can easily detect and classify the activities for the test input. So what I propose is that this can be achieved using deep learning methods such as many convolutional neural networks that can automate the process of feature learning. Like using these models, features can be extracted from a specific task, and these models are task dependent rather than having a standard procedures or features. And in this model we'll have the future learning and classification in one, which can enhance the overall model. So, like, to achieve to accurately classify the activities, the key attribute is the representation of the features. Once the low level features or the data must be analyzed effectively, and human activity recognition has its own challenges, like, for example, walking and jogging may overlap, like they seem to be similar but they are different. So all these activities, it suffers with interclass similarity, and there may be many activities in one picture. In some pictures there may be only 3 to 4 activities, but in another there may be many activities where many people are involved. So to distinguish between each activity, a good future learning framework is necessary. Next, so convolutional neural network solves this because it has many layers and many processing units that are used alternatively. The architecture allows them to analyze the data very efficiently, and the low level layers will have basic movements, and the high level layers will have the combination of these basic movements which form one activity. And the input for this model is a time series signal which is collected from the accelerometer or gyroscope applications that are built on our Android phones. And this convolutional neural network models are task dependent, so they can extract the salient features of an activity. Yeah, as I said, the higher layers obtain the line patterns of signals at higher level representation. But, and the challenges in our problem are, these processing units which are present in CNN must be applied along temporal dimension, and this is the architecture of the CNN model. We have convolution layer, max pooling layer, and again one convolution layer which is direct which is which is connected to fully connected layer, and this layer again connects to softmax layer. Now coming to the project demonstration, I will give a quick demo of my project. If you consider this one, I defined some number of functions to read the data and to do some operations. For example, if you take this read underscore data, it reads the input data, and returns a pandas data frame. Here, see, here is my input data which is read using read underscore data method. and each component of the activity is normalized using feature underscore normalize method. Like we have x-axis, y-axis and z-axis components, so each of components values are normalized. And next, coming to the plot activity, uh, we are plotting the activity using plot underscore activity method. If you see, this is the plotting for jogging. Yeah, this whole output is generated by plot underscore activity. I'm using Jupyter notebook to effectively represent the activities. Now coming to the next, this segment underscore signal, it will generate the segments and append the signals to each segment. If we go through the method once, yeah, here you can see that it returns segments and labels associated for that segment, and these labels are generated using by calculating the number of activities, the based on the count for each segment. And next, coming to the line number 25, here the given data set is divided into training and testing data set. We are considering 70% of the given input as is for training, and remaining 30% is for testing. If you consider this line 26, we are initializing the all variables required for CNN model. If you take like consider this weight underscore variable and bias underscore variable method, these are used to initialize all the variables required for the CNN model. And this apply underscore depth wise con method, like it generates the convolutional layer depthwise, and the output generated by this layer is passed to the ReLU function, which in turn passes the modified value to the max pooling layer. So these are the placeholders, and we use the gradient descendant operation. And if we see, in the last block we train the model. Like it took around 3 to 4 hours for me to train this model, and I got the result as training was 42% and testing accuracy is also 42% for large data set, whereas for other data set uh, I got training accuracy of 92% and a testing accuracy of 89%. Now coming to the next picture, yeah, performance evaluation. If you take mean and variance model, CNN model, SVM, and these are the average F measure, normalized F measure and accuracy. For the CNN model, the CNN model has got the best result. Now, so yeah, so in this approach we have used the CNN to investigate or uh, to identify the activities, and the CNN model has convolution and pooling operations, and this is task dependent as there are many layers and operations are performed on each layer. these are task dependent, and the output layer maps into human activities. So now coming to the advantages of this method, as I said, this is task dependent, and feature extraction and classification are involved in one model, so that the overall model is enhanced. Yeah, and this is end of my project demonstration. Thank you.